Good morning, everyone, and this is thermodynamics lecture number 2. And what we were discussing in the last class, if I have a quick recap, we were trying to discuss, I think, calorimetry. We were discussing calorimetry, and we had seen what is calorimetry, and we had seen somewhat. We had seen some formula for calorimetry. We had seen what is specific heat. We saw that for any process, if I give heat to any body, its temperature changes, and delta Q, the amount of heat, is ms into delta theta. We saw this, yes or no? Please raise your hands and tell me. We saw this for any process where the temperature changes, delta Q is ms delta T. This S was specific heat. If it is a change of state, the heat given is m into L, where L is known as the latent heat of melting, or latent heat of fusion, or latent heat of vaporization. Do we all see this? Do we all recollect this? Please let me know. Yes. Now is the time that we move ahead. Did you get the sheets that I had sent to you for calorimetry and thermodynamics? Sheets are there? Yes, well done. So better late than never, you got the sheets, and I'm pretty happy that you have received those sheets. Now, it's my duty to tell you that we had, I think we were here on this phase change, yes or no? We had discussed this phase change, m into L. That was the last slide that we had done. And I also told you, what did I tell you? That latent heat of fusion, or latent heat of fusion of ice, or melting of ice, is 80 calories per gram. And for steam, to convert water into steam at 100 degrees Celsius, we will need 540 calories per gram, or 540 kilocalories per kg. If I convert it into joules, it will be 4200 multiplied by 540 joules per kg. Now, what is the first thing that we are going to discuss? Obviously, we are going to discuss some questions and answers. But before going into any question and answer, this is what we will discuss, which is sometimes known as the heating curve or the cooling curve of a body. And I'm going to show you in big screen. And here it comes on the big screen. Oops, I think a part of it is missing. So what I'll do is I will increase it further so that you can see the entire picture now. Okay, all of us can see this, I hope. What is plotted on y-axis is the temperature T. What is plotted on the x-axis is whatever heat I am giving to the body. Remember this diagram. Same diagram will come as question. Please remember this. Now, the first section that I see, which I will be painting in blue, is the section where it is in solid state. We are talking about water. We're talking about water. So water in solid state is known as ice. If I have ice at some temperature, obviously it has to be less than 0. If I give heat to that ice, the temperature of that ice will increase. Yes or no? Can I have some raised hand that we understand this? Temperature of that ice will increase, and that is shown by this graph, which is inclined at an angle theta. This graph is inclined at an angle theta. Okay, now the temperature of ice will rise, and at some point it will reach its melting point. Melting point for ice is 0 degrees Celsius. Now, if I give heat to this ice, which is ice at 0 degrees Celsius, temperature will not change, but here the phase change happens. Do we understand this? Ice is getting converted into water. Raise hands will tell me that we have understood this. Ice is getting converted into water. This is the phase where ice is melting into ice. I can call it the melting phase. At this point, it is pure ice. Ice at 0 degrees Celsius. At this point, it is ice at 0 degrees Celsius. And at the red point, it is water at 0 degrees Celsius. Do we understand this? Can I have some raised hand that we understand this? Great. Now I keep giving it more heat. Now water will start to boil. It will start, the temperature will start to increase. That is given by this phase, water. Now it has come into liquid space. If I heat it, at some point in time, it will reach its boiling point, which is 100 degrees Celsius. This is the phase where we define it. This is the vaporization phase, or water is getting converted into vapor. I hope you understand this. Yes or no? Raise hands will give you more confidence. Great. At this point, it is again pure water. But if I change it into green, at this point, it is pure vapor. Water has converted into water vapor. Do we understand this? And after this, the steam, when I give more heat to this water vapor, the temperature of steam will keep on rising. Do we understand this? Can I have some raised hands? Well done. Now, I would also like to tell you here some more points. For example, in this blue phase, here in this blue phase, the temperature of ice is changing. The heat given in this process, delta Q, will be equal to M into specific heat of ice into delta theta. Do we understand this? I need real sense from everyone. Well done. In this slanted line, the heat given is M into specific heat of ice into delta theta. In this melting phase, the amount of heat given, delta Q, will be equal to mass into latent heat of melting. Do we understand this? Of ice, which is 80 calories per gram. Okay. As we move further in the red zone, and along this slanted line in the red zone, the heat given in this process, delta Q, will be equal to M into specific heat of water into delta theta. Remember, specific heat of water is 1 calorie per gram per degree Celsius. Specific heat of ice is 0.5 calorie per gram per degree Celsius. Do we understand this? Well done. Now, if I come to this red vaporization phase, the amount of heat given, delta Q, will be equal to mass into latent heat of vaporization. Do we understand this? Yes. If I come back again to this green zone, in this green zone, delta Q will be equal to mass into specific heat of water vapor into delta theta. Do we understand this? Well done. Now, I hope you have written this much. I'll give you time to write it. Don't worry. Let me now talk about this theta 1 and theta 2, and I will use this pink ink. Let me talk about this theta 1, theta 2. Now, this theta 1 and theta 2 are the angles at which these two lines are inclined. Now, remember, this theta 2 basically stands for the specific heat of water, and this theta 1 basically stands for the specific heat of ice. If the specific heat is more, the line is going to be less bent. Sorry, the line is going to be less bent. Specific heat is less, the line will be more straighter. So it depends on the specific heat. It is inversely proportional to the specific heat. You can say more specific heat, the line will be flatter. Less specific heat, the line would be more erect. Now, which specific heat is more? Specific heat of water or specific heat of ice? Specific heat of water is more, specific heat of ice is less, and therefore this is written ulta. Therefore, this theta 1 angle will be more than the theta 2 angle. That means ice wala line will be more, having more slope, and water wala line will have less slope. Do we understand this? Can I have some raise hand that we understand this? That means it will take more heat for water to increase its temperature. It will take less heat for ice to increase its temperature. Do we understand this? Now, let us talk about this L1 and L2. L1 and L2. L1 stands for the specific, latent heat of melting of ice. L2 stands for latent heat of vaporization of water. We all know which is more. Latent heat of vaporization of water is more, and therefore the length of line L2 will be greater than the length of the line L1. Do we understand this? Why this is more, why this is less? Because it will take more heat for water to convert into vapor. It will take less heat for ice to convert into water, because latent heat is different. Latent heat of ice is 80 calories per gram. Latent heat of water, vaporization of water, is 540 calories per gram. So these are the things that you should remember. If any question comes and they ask you what is this, I have told you everything that you need to know. Now I'll give you a minute so that you can note everything down. You should not write it on the sheet. If you can write it on the sheet, it's good. If you can draw it, it would be better, so that you can draw the diagram bigger, and then you can note down whatever is given. Is there any doubt in anything? If there's any doubt in anything, please raise your hands. Else I'll give you a minute to write it. Okay, no one seems to have any doubt. That's good. You will have time to note it down. I'll give you 2 minutes. Note down the diagram very correctly. If you can draw it in the sheet itself, well, I think the diagram is very small in the sheet. Only occupies a very small portion of the sheet. So you might not be able to draw everything on the sheet itself. So better you draw it on your notebook, bigger diagram, so that you can understand everything. A minute. Have you noted it down, bacha? Shall I move ahead, girls? Well done. Now, as the ritual is, we will be solving a question. And I hope that you can solve this question on your own. I would be very happy if you can do that. This comes example number 5 from your sheet. Find the amount of heat released if 100 grams of ice at minus 10 degrees Celsius. So I have 100 grams of ice at minus 10 degrees Celsius and I have to convert it into 100 grams of steam. Mass cannot change, remember that, at 120 degrees Celsius. I'll give you a minute to do it. Any idea how will you do this? Well, no values are given, so you must understand the specific heat of ice is 0.5, latent heat of ice is 80, specific heat of water is 1, latent heat of water of vaporization is 540, and specific heat of specific heat of specific heat of steam is 0.5 as well. How are you going to do this? Do you need any hint? Or you can do it on your own? So you will have to do it step by step. And let us go on to the first step. Okay, so basically how you do any question of this nature, you will do it like this. So basically what you have to do, what we have to do is to convert 100 grams of ice, which is at minus 10 degrees Celsius, into steam at 120 degrees Celsius. Please raise your hands and let me know that we know this. Okay, now how do you go about this? How do you go about this? So basically, first of all, you have got ice at minus 10 degrees Celsius. You will try to convert it. You will heat it up, and from minus 10, you will bring it to 0 degrees Celsius. Yes or no? So that is how you will bring it up. Minus 10 degrees Celsius where you have got ice. You will convert it into ice at 0 degrees Celsius. Here. And how do you do it? Ms into delta theta. Mass is given as 100 grams. Mass is given as 100 grams. Yes. Change in temperature from minus 10 to 0. The change in temperature is 10. and this half is the specific heat of ice. Do we understand this? Can I have some raise hands, girls? So now I have converted. Now I have converted ice from -10 to 0 degrees Celsius. What is the next step? Now I will start melting my ice. Melting my ice, melting my ice, melting my ice. Step number 2, we have started to melt our ice. So right now we have 100 grams of ice at 0 degrees Celsius. We will convert into water at 0 degrees Celsius. For that you will need latent heat M into L. M is 100, L is 80. 8,000 calories is what we need. Do we understand this? Raise your hands and let me know. Girls are not there in the class. They are sleeping. Do we understand this, girls? Yes, yes, we understand this. So we have two heats here, 500 calories and 8,000 calories. But we have only reached 0 degrees Celsius. We have to move further ahead in life. Yes or no? What is the third step? What is the third step? We are at we have converted ice into water, and now we are going to increase the temperature of water from 0 degrees Celsius to 100 degrees Celsius, because after that water is not water, water will become vapor. So we'll take water from 0 to 100. For that you will need ms into delta T. Mass is 100, mass is 100, specific heat is 1, and change in temperature is 100. We need 10,000 calories for this. 10,000 calories for this, and we arrive at 100 degrees Celsius ka water. Raise your hands and let me know that we have done this. Girls are sleeping. Okay. So now we are where? We are where? We are at 100 degrees of water. But now I will have to convert this 100 degrees of water into 100 degrees of steam at 100 degrees Celsius. Yes or no? Yes or no? Let me know. Yes or no? How do I do it? Mass into latent heat of vaporization. Mass is 100, latent heat of vaporization is 540. I have 54,000 calories that I need. Yes or no? So now I have 100 degrees ka steam, and now I have to convert this 100 degree ka steam, 100 degree ka steam. So at the bottom I have 100 degree pe steam, and I have to convert it from 100 degrees to 120 degrees per steam. Yes or no? For that, I need ms delta T. Mass is 100, change in temperature is 20, and specific heat of steam is 0.5. I need 1,000 calories for this. I hope all of us understand this. Yes or no? How much is the total heat that I need? I add all of these heats and I will get my answer. Did anyone get your answer? Did anyone get that answer? Can I have raised hand that we got this answer, sir? Got the answer? Good. Any doubt? Anywhere, any doubt? Explain in shortcuts, sir. There is no shortcut here, bacha. I have to go step by step. There is no shortcut. I had ice at -10 degrees Celsius. I had to convert it to ice at 0 degrees Celsius. Step number 1. Step number 2. I had ice at 0 degrees Celsius. I had to convert it into water at 0 degrees Celsius. Then I had water at 0 degrees Celsius. I had to convert it into water at 100 degrees Celsius. Step number 4, water at 100 degrees Celsius has to be converted into steam at 100 degrees Celsius. Then last step, steam at 100 degrees Celsius has to be converted into steam at 120 degrees Celsius. So I'll write those steps. And I hope you can make sense of those steps. I hope all of us are there in the class, and I'll write it again. I hope you can see this. So I had 100 grams, 100 grams of ice at minus 10 degrees Celsius. The first step is to convert it at ice at 0 degrees Celsius. Do we understand this? For that, I require heat, and the heat in this process is M into specific heat of ice into delta theta. That is my first step. From this first step, I move on to the second step and I convert it to water. Water at 0 degrees Celsius. For that, I require latent heat M into L, latent heat of melting of ice. From here, I move on to the third step. And the third step is I convert this entire water to water at 100 degrees Celsius. For that, I require mass into specific heat of water into delta theta. I have water at 100 degrees Celsius. Now I will go to the next step and I will convert it into steam at 100 degrees Celsius. For this, I require mass into latent heat of vaporization of water. Then I have steam at 100 degrees Celsius. I will just convert it to steam at 120 degrees Celsius. The process is mass into specific heat of vapor into delta theta. Do we all understand this now? Shall I give you one more question that might help you in solving this? Do you need one more question or are we good? Shall we move ahead, beta? One more question I shall give you. And this is the type of question you might expect in the examination hall. And now this is from your thermodynamics wala sheet. Here it comes. And I hope that you can do this one for me. The amount of heat required to convert 10 grams of ice at minus 10 degrees Celsius to water at 10 degrees Celsius. I'll give you a minute to do this. Are we confident of doing this? Girls, can we do this? Yes or no? I'll give you a minute. Anyone got the answer? Yes, well done, bacha. You got the answer. I am pretty happy. What about girls? Did we get the answer, bacha? Well done. Very nice. So how many steps are involved here? There are very less steps involved here. And the steps are coming on your screen right away. Do we see these steps? Do we see the steps? I have ice at minus, oops. I have ice at minus 10 degrees Celsius. First of all, I will take it to 0 degrees Celsius, m into s into delta theta. S is the specific heat of ice, remember that. Then I have ice at 0 degrees Celsius. I will convert it into water at 0 degrees Celsius, m into L. I will write it here, m into L. Latent heat of melting of ice, 80 calories per gram. Then I have water at 0 degrees Celsius. I will take it to water at 10 degrees Celsius because I don't have to go any further. I have to stop at water at 10 degrees Celsius. M into S into delta theta. Mass is given. Specific heat of water is 1. Delta theta is 10. We just put the values. Get the answer. Stay happy. How many of you got happy with the answer? How many of you got happy with the answer? And here are the calculations. Please raise your hands of all who got the answer. Hey, girls did not get the answer. Shameful. Girls, you did not get the answer. What happened? What happened? Where did you lose it? Tell me. Any doubt? Please let me know. I'll give you 2 minutes to note this down. If you have any doubts, please ask me. Everyone can have doubts. I also have lots of doubts in my life. There's someone that you can consult. There's someone that you can go, sit, ask your doubts. You must go to that person. For you, I can be that person. I'll give you a minute, 2 minutes to note it down. Shall I move ahead in life? Yes. And here are some of the important points that we have already seen. Please note them down in your sheets. As you can see, questions have come directly from this point. Heat absorbed. Someone takes heat, that is positive. Someone gives out heat. Heat is like money. If you get money, it is positive in your bank. If you lose money, it is negative in your bank. Debit and credit. I hope you understand this. Debited means gone. Credited means coming. Ice converting into water, mass remains constant. We must understand this. Volume of water is always less than the volume of ice because density is mass divided by volume. Density of water is more than the density of ice. Do we understand this? Yes or no? Yes, sir. Remember that, sir. Latent heat of melting or latent heat of freezing is same. When ice is melting, we call it latent heat of melting. When water is freezing, we call it latent heat of freezing. 80 calories per gram. Water, when it is getting converted into vapor, mass remain constant. Volume of liquid is always less than the volume of vapor. Remember that. Volume of liquid is less than the volume of ice. But volume of liquid is always less than the volume of vapor. 1 gram of water is this much in vapor. Very important. Question has come on this. Latent heat of vaporization is 536. We take it as 540. I'll give you a minute to win it. Note it down. Same question will come in the exam. Have you done this? Girls, no chit chatting, only talking, only studying. Now, again, some important points. Remember, the formula that I am giving you, they are not supposed to come. They're only supposed to come when they make a very difficult question in this chapter. I have seen such question coming in JEE Main and Advanced, not in your NEET. But still, you must know, for melting, you always use the formula M into L. Any doubt, anyone? Okay, for melting, use the formula mass into latent heat. That is the amount of heat which is required. Now, sometimes I don't think they will ask you what is the work done in a melting process or vaporization process. Work done is always P into delta V. This delta V stands for change in volume. Do you understand this? Delta always stands for change. Change in volume. Change in volume is always final volume minus initial volume. Do you understand this? So, for ice melting, the formula will be how much pressure we have applied into final volume, volume of water minus volume of ice. Do we understand this? Similarly, for vaporization, it will be pressure multiplied by volume of vapor, final volume minus volume of liquid, initial volume. Change in internal energy, they might ask, this is the most difficult question that can ever they make. This comes from first law of thermodynamics. First law of thermodynamics is delta Q is equal to delta U plus delta W. We will be doing this in details right now. Just remember this. So from here, you can find the value of delta U. Delta U is the change in internal energy. That will be equal to delta Q heat minus delta W, which is work done. I'll give you a minute to note this down. They might not give you a numerical on this, but they might ask you the formula, and that is why it is there in your sheet. A minute, 2 minutes. Have you noted it down, bacha? Okay. Then again show you this diagram, and now it is in bigger picture. And now you might see it in your sheet on thermodynamics. Do you see this sheet on thermodynamics? Do you see the same diagram? Yes or no? This is your heating of solid, ms into delta theta. This is melting of solid, m into l. This is heating of liquid, ms delta theta. This is boiling, m into latent heat of vaporization. This is superheating of liquid. Do you all understand this? Everything is written. This angle is alpha, this angle is beta, and this angle is gamma. Do we see these angles? Now they will give you some important information about this alpha, this line of this, the length of this. We already know length of this and length of this, how they are related. Do we know this or not? We also know which angle is more, and which angle is less. Which is the angle which will be the most, alpha, beta, or gamma? 1, 2, or 3. Which is the angle which will be the highest angle? Alpha or beta or gamma? Which will be the highest angle? Alpha will be highest, yes or no? Then it will be beta, then it will be gamma. All these informations are given in this. I will just give you a minute to note this down. Whatever I had told you is here in this paragraph, in this slide. I hope all of you can see this paragraph, this slide. A minute to win it. Have you all noted this down? Are we ready to move on to the next step? Okay, we'll be doing questions, but just let us finish these parts. Fatafat. Again, this is evaporation and vaporization. You must understand, because the question has come straightforward on that. Vaporization is possible only at a particular temperature, boiling point, or whatever you call it, vaporization point. Evaporation, it is possible at all pressures, at all temperatures. Here liquid needs to be heated. Here there is no necessity of liquid being heated. It is a surface process. It is a very slow process. It happens only on liquid surface. It can happen at the entire liquid. This is a very fast process. The temperature of the substance or the body decreases when it evaporates. Do we all understand this? You may not have to note this down. You will have to just read it from the sheet that is given to you. A question can come directly from this. Do we all understand this? Yes or no? Yes or no? You have to read it. Yes, sir, you have read it, sir. That is very good, sir. Then we come to this diagram and I will just, because this diagram can come and it might look very complicated, but it is not so complicated if you understand this. So I'm now moving on to this diagram, which is also there in your sheet. And here it comes. Here it comes. I can see you. I can see you. You can also see the diagram. Here I have different lines. I have different phases. Solid to liquid conversion, which is melting, or the M curve. I hope you can see the M curve. Please raise your hand if you can spot the M curve. Yes or no? Yes. Then I have liquid vapor conversion, the vaporization curve or the V curve. You will have to remember this diagram very carefully. Where is the V graph? This is the V graph. This is the V graph. I hope you can all spot it, the V graph. Then I have straight away from solid to vapor, we call it sublimation. S graph, S graph, S graph, S graph, S graph. These are the three graphs that you see at different pressures. The graphs are different. And you see one point where all these three meet. Do you see this point? Yes or no? This is known as triple point. Now this is a specific point which comes at a specific pressure, specific temperature, in which water can exist, or any substance can exist in all three stages. It can exist as liquid, it can exist as solid, it can exist as vapor. This is known as triple point. Do we all understand this? Yes or no? So you just have to see it from the diagram, and you have to understand that this point is known as triple point. If they give you this diagram, they will just ask you what is this point, triple point, and the triple point of water is 273.16 Kelvin. Do we see this? Do we see this? Do we see this? Yes, we see this. We see this. We see this. This is 273.16 Kelvin. Don't forget this. Please mark what I have told you. You don't have to draw this diagram at all. You just need to remember that this point is the triple point of water. And what are the temperatures and pressures of triple point of water? That is given in the next 2 points. At triple point, all three phases of a substance can remain in conversion. That means they can exist together. Triple point of water, temperature of triple point of water is 273.16 Kelvin and pressure is 0.00625 atmospheres. I'll give you a minute to note this down. The conditions of pressure and temperature for triple point of water. Please note it down, bacha. I'll give you a minute. I hope all of you noted this. Yes, sir. Then, sir, we come to our next thing, sir. And next thing, sir, is some questions, sir. And this is the first question, sir. The thermal see sort of question that are asked that are very, very simple. Just remember simple things in life. You shall always succeed. Question number 2. This is from your calorimetry wala sheet. 2 sheets have been intermixed. This is from your calorimetry wala sheet. Question number 2. The thermal capacity of 40 grams of aluminum. Specific heat is given to you. What is the answer? Waiting for your answers. Thermal capacity. What is thermal capacity? Heat capacity or thermal capacity, HC. Do we remember the formula for heat capacity or thermal capacity? Can't get it. Uh-oh. What is the answer? Can't get the answer. Thermal capacity is mass into specific heat. Yes or no? You just multiply them both and you get your answers. And the answer is 40 multiplied by 0.2 and the answer is 8 calorie per degree Celsius. Do you all understand this? Yes or no? That is the answer. Was it so difficult? Girls? Yes, you got the answer. No. Please tell me that you got the answer. Otherwise, I would be very, very sad that you cannot do it. Shall I move ahead? Now see, this is a question from IITripleE. Heat given to a body which reaches its temperature by 1 degree Celsius is known as water equivalent, thermal capacity, specific heat, temperature gradient. See, that is the mistake that you have done. You are showing me it is C, but the answer is not C, bacha. The answer is not C, bacha. Heat, again remember, heat given to a body which raises its temperature by 1 degree Celsius, that is the thermal capacity. If it was 1 gram of a body or 1 kilogram of a body, then the answer would have been specific heat. It is per calorie, heat per degree per gram or per kg. Do we all understand this? A simple mistake will give you -5. You have got -5 because you did not see gram. This only comes when it is per kg or per gram. Do we understand this? Yeah, so you see, this is how you can make a mistake and then you will fall flat. Then let me see, most of the questions are from that CP/CV wala thing. I hope I have opened the right exercise. Okay, CP/CV we have already done. Chalo. Here it comes. One more, the last question. Oops. And this is how it is there. Most of the questions are from CP and CV, which we have already done. Thermal capacity of any body. This is quite new. A measure of its capacity to absorb it, a measure of its capacity to provide it, the quantity of heat required to raise the temperature by unit degree, the quantity of heat required to raise the temperature of a unit mass of a body by unit degree. What is your answer, bacha? Thermal capacity or heat capacity. Thermal capacity or heat capacity, they mean the one and the same thing, bacha. And the answer is, again, you have said 4. 4 is wrong. 4 is wrong. And the correct answer is 3. Again, you made the same mistake. Again, you got -5. Shame on you. Shame on you. Shame. Same mistake, same question, same mistake. Well, I can't say much, but I'm very sad. This is not good. You could not do this question. I'm really very sad. I told you that just before, but still you gave me the wrong answer. Very sad. But I'll give you a chance to redeem yourself. You are like cash cards. You can redeem yourself cash vouchers. And you can redeem yourself with this question. If you can give me the answer to this one, which I think is not there on your screen. Still is not coming on your screen. I think it is now on your screen. Yes or no? Oops, gone. Yes, question number 30. Oops. And I hope you can see this. Yes, sir. Let's see. This is a question that can help you redeem your splits. Yes, now it is clear. Equal mass of two liquids A and B contained in a vessel of negligible heat capacity are supplied heat at the same rate. The temperature time graph for these two liquids are shown. S represents the specific heat and L represents the latent heat. Which one is correct? Let us see. Who does this? Remember, these two lines must be straight lines parallel to x-axis. They have drawn it probably wrongly. Doesn't matter. You understand it. Tell me the answer. Redeem yourselves. Your vouchers, cash vouchers can be redeemed. Redeem yourself. Get your esteem back. Which one? 10 Which one? Whose specific heat is more? Whose specific heat is less? Whose latent heat is more and whose latent heat is less? And the answer is 4 is the answer. That is correct. 4 is the answer. Look at A. A is more slanted. A is more direct. That means specific heat is less. That means the answer can only be C or D. A and B are out of the picture. Do we understand this? A is more inclined. A has got more slope, and therefore specific heat of A has to be less than specific heat of B. So option number A and B are gone. Now we only have to see latent heats. If you can see, B ka latent heat is more than A ka latent heat is more than B ka latent heat. So this option goes away. The only correct option is option D. Specific heat of A is less than specific heat of B. Latent heat of A is more than latent heat of B. Do we understand this? Can I have some reason that we understand this? If you have done this question correctly, then I must congratulate you that you have redeemed yourself. I'll give you a minute, not for silence, a minute to go through what we have done till now in this chapter of specific heat or calorimetry. If there is anything that you want to talk about, this is the time that you tell me. A minute, 2 minutes. and then I'll give you and I'll be back after 2 minutes. Anything that you have not understood, please let me know. 2 minutes. Done with calorimetry. Now we move on to a more fascinating stuff, thermodynamics, and we start with a thermodynamic system. Now, in this particular topic, what we are going to deal with are gases. We were dealing with gases. We'll be dealing with system. Gas will be inside a cylinder. Gas will be inside the cylinder, and there would be a piston. So this entire thing becomes a system. In fact, this gas can be called as a system, a thermodynamic system. Now, when I call the gas as a system, this gas has some values which define its state. For example, if I say 1 mole of a gas is there in a cylinder at 290 Kelvin, the pressure of the gas is 2 atmosphere, and you already know the volume because it is the volume of the cylinder. These conditions, the number of moles N, the volume of the gas V, the pressure of the gas P, the temperature of the gas T. From the temperature, you can find the internal energy of the gas. You can find out the entropy of the gas. These all things, pressure, volume, temperature, number of moles, they tell us the state of the gas. These are known as the state variables, and these are known as the state variables, and it defines the state of the gas. And this entire thing can be called as the thermodynamic system. Do we understand this? If I change any of these quantity, the state of the gas will change. If I change the pressure, state of the gas will change. If I change the number of moles, state of the gas will change. If I change the temperature, the state of the gas changes. It is same as if I have a point in space. If I change the x coordinate, the position changes. If I change the y coordinate, the position changes. If I change the z coordinate, the position changes. X, y, and z are the state variables of this point. Similarly, the state variables of a gas are pressure, volume, temperature, number of moles. Do we understand this? I change pressure, state changes. Pressure is like x-axis. I change volume, y-axis, state changes. I change temperature, z-axis, state changes. I change number of moles, which is time axis, the state changes. Microscopic system, if the number of particles is very less, one single atom, we call it microscopic system. Macroscopic, we have very large number of particles. That becomes a macroscopic system. Now, these small number of particles are constantly colliding with the walls of the cylinder, and from there you can find the pressure of the gas, you can find the temperature of the gas, and so on. Do we understand this? So these macroscopic properties are bigger properties. Pressure, you can easily measure the pressure of the gas. But if someone asks you, find out the speed of the gas molecule, it will be very difficult to pick that molecule and find out the speed. Those are small properties. Macroscopic properties are properties that can be measured. Do we understand this? You can easily measure the pressure of the gas. Just put a pressure gauge and you get the pressure. You can easily measure the temperature of the gas. Just put a thermometer and you get the temperature. You can easily measure the volume of the gas, just find the volume of the cylinder. But if someone tells you, find the speed of this molecule, it will be a horrible task. Do we understand this? So these are microscopic properties. Open system, we will not be dealing with open system. An open system is a system in which heat or energy and matter, things can go out, things can come in. Molecules can go out, molecules can come in. Energy can go out, energy can come in. Such systems are known as open system. Then there is a closed system, and these are the type of system that we'll be dealing with. Only heat or energy can be exchanged, molecules cannot be exchanged, gas cannot move out and gas cannot come in. Then we have an isolated system where nothing can be exchanged, internal energy remains same, heat remains same, work remains same, everything remains same. This type of system is known as isolated system. It cannot exchange heat, it cannot exchange work, it cannot exchange matter. Do we understand this? Which type of system are we going to deal with? We are going to deal with something known as a closed system where only heat will be exchanged but not particles. When I say particles, gas molecules, the number of gas molecules will always remain same unless otherwise stated. So number of moles or the mass of the gas will remain same. Do we understand this? But the other things can change. What are the other things that can change? Pressure can change, volume can change, temperature can change, entropy can change, internal energy can change, but the number of moles or the mass of the gas will remain constant. I'll give you a minute to note it down, and then I'll move ahead. Have you noted it down, bacha? Okay, that takes us to the first of the quantities which we would be dealing, and the first of the quantities which we will be dealing is work. Without work, nothing happens. Once you become doctors or engineers, you will have to do some work. You cannot sit and live your life because that is not possible. You will have to do work, and that is how you are going to earn your livelihood. Work. Gas also has to do work. Now, how do I find work done? If I write it in differential form, small amount of work, small amount of work done, dW is pressure multiplied by dV. dV is the small change in volume. So if I integrate both sides, this will be the formula for work done. You will have to note down this formula. Work done is integral of PdV from initial volume V1 to final volume V2. Do we know this formula? Yes or no? Or you can also write work done delta W as P into delta V, where P is the pressure if the pressure is constant, multiplied by delta V. Delta V is the change in the volume. Do we understand this? Now, there are four processes that you must always remember. One is where the pressure is constant, one is where the volume is constant, one is where temperature is constant, and the fourth one when there is no heat given. No heat given, no heat taken. Now, what are these processes known as? And I'll write the name of these processes, and you will also write the formula together with it. Everyone must write. The first process where pressure remains constant is known as isobaric. Do we know this? Yes or no? Isobaric process, do we know this? Tell me. Yes. Work done is P, pressure. Pressure is constant multiplied by change in volume. Do you all understand this? The second one is volume constant. This is known as isocoric. Isocoric. Volume is constant. Volume does not change. So change in volume is zero. Therefore, work done is zero. Do we understand this? The third one is temperature is constant. It is known as isothermal. Isothermal. And this is the formula 2.303 nRT log to the base 10 V2, which is the final volume, divided by V1, which is the initial volume. You will have to remember this formula. There is no other way. Do we understand this? Or where Q is constant, or I can say there is no heat given. So instead of writing Q as constant, I will say the heat given or heat taken is zero. Delta Q is zero. This process is known as adiabatic process. We will do all these processes in details right now. Just remember the formula for adiabatic process: N, number of moles, into R into T1, initial temperature, minus T2, divided by gamma. This is the same gamma, Cp by Cv, minus 1. These are the four processes, and you will have to remember their formulae. You'll also have a graphical method. If you have a graph between P and V, work done is the area. You can see this area, yes or no? Work done is area under this graph. Do you all understand this? One more thing that you must remember is work done. We have a sign convention. It can be positive. Work done can be negative as well. When do we take the work done positive and when do we take the work done negative? For positive work, if the volume is increasing, the gas is expanding. The gas is expanding. Gas is doing work. Work done is taken as positive. If the volume is decreasing, gas is compressing. Remember, gas cannot compress on its own. Gas can expand on its own. Gas cannot compress on its own. If the volume is decreasing, then the work done is negative. If the volume is increasing, then the work done is positive. I'll give you a minute to note these entire things down and to remember these formulas, because we will be needing these formulas throughout this chapter. I'll give you a minute to win it. Have you noted it down, bacha? And I think you should not write it in the book. You should write it in the notebook. Okay. Now, when we come to this first law of thermodynamics, we will come across three terms. One is work done, which I write it as delta W. The second one is heat given, that I write it as delta Q. The third one is change in internal energy, and you must remember this sign concept. If volume increases, that is change in volume is positive, that means it is expansion of gas, that is work is done by the gas, work done is taken as positive. If volume is decreasing, that means change in volume is negative, that means the gas is getting compressed, that is work is done on the system, work done is taken as negative. Do we understand this concept for heat? If heat is given to the system, absorbed, heat is like money. If you give me money, it is positive. If you give out money, it is negative. I've already told you that. Yes or no? Then if temperature is increasing, then delta U is positive. If temperature is decreasing, then delta U is negative. Okay, so just remember this. Just take this one out. If temperature is increasing, change in internal energy is positive. If temperature is decreasing, change in internal energy is negative. Do you understand this? Please raise your hands and let me know. Raise your hands and let me know. Yes, I'll give you a minute to note this down. A minute, 2 minutes. Shall we move ahead in life? Yes or no? No or yes? Shall we move ahead? Yes, sir. Then, sir, this thing, sir, first law of thermodynamics is what you will write. Delta Q, they have written it wrongly. Delta Q heat given is equal to delta U plus delta W. We have already seen the sign convention. Yes or no? All parameters must be in the same unit. This is based on law of conservation of energy. Yes or no? All parameters must be in joule or calorie. Heat and work are path dependent. That means it depends on path. If I go in one path, heat will be different, work will be different. In isochoric process, work done is 0, heat is different. In isobaric process, heat is different. In adiabatic process, heat given is 0. So heat and work are path dependent process, but internal energy is a state function. It does not depend on path. I told you that. Yes or no? Note down these 4 points in your sheet now. And remember the sign convention. You cannot forget the sign convention, whatever happens. Have you noted it down, bacha? Then comes this. You can see this is the initial stage. Do you see this? And this is the final stage. I have gone from initial stage to the final stage in 3 different ways. This is way number 1, this is way number 2, and this is way number 3. Do we understand this? Now, work done is area under this graph. Area under this graph. If you look at the area under graph number 1, it is the highest. Then area under graph 2, then area under graph 3, and therefore this is the order of work. In first process, work done is most. In the third process, work done is the least. Do we understand this? The order of heat given is the same. Delta Q is delta U plus delta W. The change in internal energy will be same whether I go in process number 1 or process number 2 or process number 3, because internal energy, change in internal energy does not depend on process. Do we understand this? So whatever is the order of work which is coming from the area of the graph, the same is the order of heat given, because internal energy is same. Do we understand this? Yes or no? You will draw this graph and you will write these things. I'll give you a minute to win it. Have you noted down this better? 3 different processes. Okay. Then comes this one. And what is this one? This is known as a cyclic process. Why it is known as cyclic process? If you start from any one point, let us say point A, then you go to some other point B, then you come to for some point C, then you come to some point D, and finally you come back to the point A. Such processes in which the initial and final stages are same is known as a cyclic process. Most of the things that you see thermodynamic system, they are cyclic processes. Your car, it runs on internal combustion engine. In that, a thermodynamic process is happening. It's a cyclic process. Everything is cyclic. Cyclic process. Start from the same point, end on the same point. Again, then start. Cyclic, cyclic, cyclic. What is the change in internal energy? So what is cyclic process? Cyclic process consists of a series of changes which returns the system back to its initial stage. We understand this? I start from one stage. For example, I am a person. I go from point A to point B. Then I go from B to C. Then I go from B to D, C to D. Then I come back to A. That is a cyclic process. I, I come back to my starting point. We understand this? Yes or no? In a cyclic process, the change in internal energy or delta U is zero. Why delta U is zero? Because I start at point A and I come back to the same point A. There is no change in temperature, there is no change in pressure, there is no change in volume because I have come back to the same point. Change in internal energy is zero. Now, if change in internal energy is zero, then delta Q, which is equal to delta U plus delta W, first law of thermodynamics. Delta U is zero, that means delta Q will be equal to delta W. Do we understand this? For a cyclic process, heat given is same as work done. Do we understand this? Do we understand this? Can I have some raise hand that we understand this? Now, in this process, work done is always given by area enclosed by this portion. I hope you can see this portion. This is the work done in a cyclic process. Now, this work done can be positive, it can be negative. How do you find out it is positive or negative? If the cycle is clockwise, as you can see, this is a clockwise cycle, the work done is positive. If the cycle is anti-clockwise, opposite to the clock, work done is negative. I will repeat two things that you must remember about cyclic process. It starts from the same point, it ends on the same point. Delta U, the change in internal energy is zero. When delta U is zero, delta Q is equal to delta W. This is point number one. Point number two, work done if it is a clockwise cycle is positive, work done if it is an anti-clockwise cycle is negative, and work done is always given by the area between the graph. Do we understand this? Can I have raised hand that you understand this? I'll give you 2 minutes. That is the last point of this cyclic process, the last point. In the next class, we will be doing questions based on this. Don't worry, we'll do questions. I'll give you time to understand what we have done today. Please note this down. One small point is left and we will wind off the class on that point. I'll give you 2 minutes to note this down. Have you noted down, bacha? Yes. Then comes my favorite thing, and this is question and answer. As you can see, we study a lot, but the question and answers are pretty straightforward. This is the first question. First law of thermodynamics is given by which of the following? A, B, C, D, 1, 2, 3, 4. And I'm waiting for your answers. A, B, C, D, 1, 2, 3, 4. Can I have your answers, please, bacha? One, two, three, four, A, B, C, D. And the answer is, should not take so much. Answer is 1. Do we understand this? So, what has happened here? Do we understand this? Yes or no? Shall we move ahead in life? Then you have this one coming your way. The internal energy U is a unique function of any state because change in U, A, B, C, D. Change in U, A, B, C, D. A, B, C, D. And the answer is A, does not depend on part. Do we understand this? Are we happy? Yes or no? Let me see if I have more questions. And as you can see, here is one of these. Let's see if you can get this one. According to the first law of thermodynamics, A, B, C, D. I hope you can see this, bacha. According to first law of thermodynamics, A, B, C, D, I'm still not getting the answer. And the answer is C, energy is conserved. Energy cannot be created. Energy cannot be destroyed. It is only transformed from one form to another. And I have one more, and I have one more, and I have one more, and I have one more. And you can see, and you can see, and you can see, and you can see. So many times the same thing has been asked. What is the answer for this one? What is the answer for this one? A, B, C, D. There are two laws given here. Law of conservation of energy, law of conservation of mechanical energy, law of conservation of gravitational potential energy. And the answer is which one? Don't get confused. Answer is one. Law of conservation of energy. Do we understand this? Yes or no? No, yes. One more. One more. One more. Plus 5. Sorry, plus 4 or minus 5. This will get you into aims. Let's see who gets into aims. From the following, which depends on the parts. Dang dang, dang dang, dang dang. A, B, C, D. Let's see who gets me this one. Let's see who gets into aims. Is anyone getting into aims? From the following, which depends on path, and you are saying 4, so you got minus 5 and aims is gone. So now you have Sarkari colleges left, aims is already gone. Which of the following depends on path? And the answer is P into dV. This is work done. We have forgotten this. Shame on us. Shame on us. Minus 5. Shame on us. But again, as I always tell you, last question. No, not last. Maybe I can have one or two more. To redeem yourself. Let's see who gets into the part of redemption. Shawshank Redemption, one of the most anticipated movie of all time. Shawshank Redemption. Can you redeem yourself? And this is the question which will help you in redeeming yourself. Read the question carefully. Understand the question carefully. And let me see if you can give me the answer for this one. An ideal gas goes from state A to B via three different processes. Q1, Q2, and Q3 are the heat given. Delta U, delta U1, delta U2 are the energies. Which is correct? Let's see. Who gives me this one? Let's see. Who gives me this one? A, B, C, D. Goes from A to be in different processes. Which is the following? Which is the correct answer? If you are taking so much of time, bacha, that means you are on the wrong track, bacha. I'm also giving you background score. And the answer is 4, and that is absolutely wrong. -5. And you have lost your last chance of getting into a government college. Shameful. And your hard work goes down the drain and it gets flushed out of the system. Option C and option D are option C and option D are absolutely foolish, absolutely wrong. From A to B, whatever path I take, internal energy ka change has to be same. So the answer has to be from 1 and 2, A and B. And the correct answer is A, but you have lost your chance, beta. You could not redeem yourself. So your cash voucher is invalid now. I'm sorry to say that. I'm very disheartened, but you are invalid. Invalid vouchers, and I don't take invalid vouchers. Invalid vouchers are useless. Invalid vouchers are useless. We are invalid voucher now, but I'll give you one more chance. This is a Flipkart sale. So you get one more chance to redeem yourself, and the chance comes in the form of this question. If you can redeem yourself, well done. If you can't, you are useless vouchers already. Can you redeem yourself? Q, E, and W denote heat, change in internal energy, and the work done in a closed cyclic process. Cyclic process. A, B, C, D. Let's see. Can you redeem yourself? Is redemption possible? Shawshank Redemption. The highest rated movie ever on the IMDb charts. Triple R is not there. I'm sorry. Shawshank Redemption is definitely there. Can you redeem yourself? A, B, C, D. What is the answer? You're taking so long. Answer is definitely wrong. Answer is A. Change in internal energy is 0 in a closed process. I'm sorry. You have lost all your chances to get into a AIMS. AIMS is already gone there. Government colleges gone there. Right now we are at private colleges, and your parents will have to pay a lot of fee for that. And the entire blame goes on to you and to me that we could not remember what is a cyclic process. So -5 to you. And probably you have lost the private college. Even in private colleges, you have seats where the fee is low. But I don't think you will get even that college if you can't give me the answer for this one. Sorry, you could not redeem yourself. Really very sorry. I'll give you chance in the next class to redeem yourself. To redeem yourself, I will give you a chance. I'll give you a chance. Here. No, I can't give you a chance. Well, just to make end things on a good note, and I always want to end things on a good note. Can you tell me the answer for this one? You can see it has come multiple times in the exam. Can you redeem yourself again? Yes. Chalo. there is still chance that you can get into a private college ka government seat where you will have to pay less fees, but I'm really not happy with the performance that we have done today. I hope that in the next class we will be doing better. Yes or no? So today you go back and you study whatever we have done for today, because if you don't remember it in the next class is going to be the most difficult class ever that you have encountered, because we'll have to use everything that we have studied in today's class in the next class. On that note, I will wind off today's class. Go through this recorded lecture once again, and if there's any doubt, I am always there. Take care, have a nice day, and I hope you study. And remember, whatever questions we have done, same questions will come in the examination hall. Remember that. Take care, have a nice day. God bless you all.